I've wrote some software for school, and the client has asked for some extra inputs and outputs to be enabled. These are in red: the boiler pump, 1, 2 and 3 fault, and the enables. They've also added, which aren't in red, the boilers 1 run, 2 run and 3 run. Now normally a gas boiler would have its own pump and it would control itself, but in this case they've asked for me to control the pumps for the gas boiler. So I've wrote the logic already to save a little bit of time. So these are the extra points that I've added in. So we've got fault boiler 1 pump, 2, 3, and then of course we've got the runs. So all I've done here with the runs is take them into a mismatch alarm. So it's an XOR gate. So basically we start the pump, the boiler, sorry. So the boiler started there, and then the pump is started. So this off delay is coming from the same output as the boiler, but I've put 6 minutes off delay. So when that boiler is disabled, that will not disable this boiler pump 1 for 6 minutes. So it's got a run time, so it can actually clear the heat from the boiler plate heat exchanger. So we're not actually shutting off the pump immediately when we shut off the boiler. So all we've done there is put an off delay of 6 minutes. I'll open that up for you. Off delay 6 minutes. So after this is disabled, the boiler, the pump will carry on running for another 6 more minutes just to clear the excessive heat. So that's simple enough, but we need to also incorporate the runs for the boiler. So because we're now getting the runs, i.e. the boiler is running signal, then we put it into a mismatch alarm. So this is the boiler enable signal for boiler 1, and this is the pump run signal. So, and what we're doing, we've got an on delay 10 minutes here. The reason being is 6 minutes we know it's going to, we know that XOR gate is going to trigger immediately we turn that boiler off, or immediately if that pump is not running, because it's basically a mismatch. So we can't put anything less than 6 minutes. So I've just put 10 minutes on delay there, so that this will go true if the boiler pump, if the boiler is stopped and the pump's still running, this will then go true. So we'll wait 10 minutes, and then after 10 minutes we're sending an alarm, mismatch alarm, and that's enough to cover for the run signals. But the other issue we've got is the boiler fault pumps. We don't want to start a boiler if the pump is in fault. Now the logic for the boiler is working on this lead lag object, lead lag runtime block here, and it would start the least run hours of the boiler first. So in this case that would be this boiler runtime B, so the second boiler. So it would start that first, and then the next boiler to come in will be boiler 3, and then the next boiler finally to come in, if it needed it, would be boiler 1. But boiler 1, as you can see, has been running for 35 days 1 hour. This is still not been put onto the controller yet, so the panel's still being built, so you really just need to ignore these days at the moment. But what will happen is once we get an input, everything is healthy, and we get an input into the system, then it will start first boiler B, i.e. boiler 2, then it will start boiler 3, then it will start boiler 1 if required. But what if it's a pump's in fault? There's no point in starting any of these boilers. So all I've done here is the fault signal from the boiler I've put into a NOT gate. The reason I've done that in the logic is it may be the other way round. So a healthy of a boiler may be true, and then in that case all I've got to do is change over this point to the out instead of using the in. So I've put that just to save time when they're commissioning it, but I'm expecting the point to be false in healthy and to be true in boiler fault, but that's not fail safe. So if someone cuts the cable, we're never ever going to have a true. So normally to make it fail safe, you would always have a true there, and then i.e. the circuit's made, and that's fail safe. So if anyone cut the cable or disconnected the cable, then that would not be true and that would be false. But in this case, this I think is going to be not fail safe. It's going to be in a situation where if it goes into fault, the boiler will give a signal. And all I've done here is added all them three together in an AND gate. So if all them three are faulty, I just put up a fault saying all boiler pumps are faulty. We've done the same with the gas boilers here. Any of these three go into fault, all of them are in fault, sorry, not any of them, all of them are in fault, then it will put the gas boilers faulty up there. But with this pump, what I have done is I've added in some extra logic so that if the pump is faulty, I give a long value, all these 999s here. I think there's about 13 number 9s. So that this value is sent to the runtime of the pump. So let me put boiler, well, I'll do it for boiler 2, fault on boiler 2 pump. So you look there, we've got 2 days, 5 hours. So I'm going to put that into fault. So it's never going to run now boiler 2. The next boiler it's going to run is boiler 3, then it's going to run boiler 1, and of course it's not going to run boiler because it's already in fault. It's not the boiler 2 is not going to run at all because the pump's in fault. I'm going to take that back off. Emergency auto. So that's the boiler pumps done, and the rotation of the boilers. If a pump goes into fault, then of course it won't run that boiler as the first boiler to run. And then of course we've got the mismatch alarms using the run signal, and that basically covers, or it should cover, the job for that. I'll just, while I'm in here, I'll just show you some graphics. So frost protection, sorry, it's popped up on my other screen, let me just move that across. So they can set the settings there for the frost protection. Optimizer, again that's gone on my other screen. Let me just, there's your optimizer. Outside air VT. So that's calculating, depending on the outside air temperature, we'll calculate the set point. There's nothing connected yet, so that's why it's saying 0 for outside air. So because it's 0, or it thinks it's 0, it's doing the high heating set point of 70 degrees. Pumps, it's probably going to pop up again. Yeah, they're all popping up on my other screen. Bring that across. So there's the pumps. Reset the pumps, auto rotate, or you can manually select a pump to run. So there's no need to go through them. The valves, we didn't do the valve. Look at the valve. Simple pop-up for the valve. So calculating heating using the outside air, but that can be changed for manual heating if you want to. Gas boilers. Well, that's it. One gas-fired boiler used for the domestic hot water, and then the other boilers. Okay, this is popped up in here now. So we've got the 3 boilers, we've got the different pumps, and some VT valves. And then we've got different fan connectors around the convectors around the school. I click on one of them. That's a pop-up on the other screen. Bring that across. And that's just showing the fan, the heating element, giving you the space sensors, temperatures of the different areas. And of course you can adjust the set point. For the logic, if I views wire sheet, so this is how I've written the logic. I've got my folders for my pumps here. I've got my folders for my valves here. I've got my main boiler folder which we've been in, and I've got the HWS gas fired. All the space temperatures of the building, and then naturally the minimum is going into the space optimizer, and also the frost protection. I'll show you the frost protection logic. Views, wire sheet. Simple enough. Outside air, stage 1 protection for the outside air, stage 2 protection for the water, i.e. the return or the flow of the main gas boilers. If it goes below 20 degrees, then we go through a stage 2 protection where we actually start it up just to stop any frost. And then the space temp, so if the space temp goes below 14 degrees, we'll go into stage 3 protection and run some heat through the building. I mean, if the outside air exceeds 18 degrees, we can actually stop the heating. Still use a domestic hot water, of course, because you still need domestic hot water, but we can stop the heating of the system. Outside air VT. It's just views, your sheet. So it's just a standard reset block. It's that one that we're using. There's no cooling here on this job. So it's a standard reset block with values going in. This works on a linear curve as per the picture. So if I go back to the picture, if I just double click that, you can see the picture here on the linear curve. And of course we've got the option of not using that and putting a manual set point in for the heating. Space optimizer. Views, wire sheet. This is a space optimizer software. Normal scheduler. Going into these blocks, into the optimizer start stop. The outside air temperature going in there, and the space temperature going in there. And of course this is the output to say enable or not. So we'll follow that through, and there's your enable. You start with your system. So we're enabling the gas fired one at the moment. But again, this is not live, so it's just software written. We've still got to commission it yet. Safety folder, so your pressure fire, to shut down fans if need be. This would just be a basic, yeah, it's just basic pressure fire alarm. Again, the NOT gate is used in case that pressure is fail-safe or not fail-safe. I can just move the point without having to mess around with anything else. Let's go into one of these. Wire sheet. So an enable for safety, because naturally if there's a fire you don't want these convectors running. it in auto, so you can actually change that. Auto, override on, override off. Got those options there. Oh, using a loop point, so the set point 21, control variable is the minimum space temperature for that area. So if this was enabled, it would actually start ramping up, and it's not enabled because of the safety. So let's emergency activate that. Yeah, that's now enabled, sending the signal, and that's creeping itself up, but greater than 10%, I enable the unit. Take that safety off. Follow that through. Safety, double click that. So safety is false because of the fire alarm. Let's follow that back through. To my inputs folder. And because these modules are not online yet, actions, set. So this is actually wrong anyway, so that needs to be changed to say healthy. So it's fail safe, false is fault. And then we need to change the Boolean state of alarm. Okay, so healthy. The reason this alarm has come up, the mismatch, is wanting the boiler running there 10 minutes. So that's come up because we've actually got that into the wrong place. And that's in the wrong place. Okay. But that after 10 minutes, that will alarm. And then after 10 minutes, boiler 3 will alarm unless we actually override that one and that one. Okay, they've gone off false now. So it's running boiler 1 and boiler 2. Sorry, boiler 2 and boiler 3. Boiler 1 is not running because it's the least run. Sorry, it's the maximum run hours, and it doesn't need boiler 3 yet, boiler 1 yet. So it's decided not to. Now it has decided to run it now, and that is because the set point is 70. The control variable is 0, i.e. no temperature, because we haven't got a sensor attached to it at the moment. So hence that's why it's quickly gone up to 100%. And if I don't override this one, this is now true. So if I don't override the one for that one, it will go into alarm. Now it won't. Let's take all these off. And we can go back and take off the... These are in alarm purely because we haven't got the run status back from the pump. Because, again, it's not even... It's just software at the moment. It's not a live system. So until that time, you are going to get alarms. But at least it proves the system, it proves it works. But there's always going to be slight changes to do once you're on site or commissioning it remotely, once it's all been installed and panels been installed. And I'll just take the safety off. So and that should shut everything down. Yeah. Something here. Okay, that's the enabled there. Primary heating pumps enabled. Off delay 20 minutes. Hence that's still got a true there. Yeah, these would be cancelling themselves down now. So we've got a true here, which is keeping that on. And the secret's linear, I believe. Yeah, 1 minute delay. Boiler 1's off, boiler 3's off. That was the first, so that will go off in a moment. These pumps won't go off. They're not asking for the pump now, but there's a 6 minutes run on time, as I was mentioning to you. So just to clear any heat from the boiler, so they're still enabled. Let's see why these are enabled. Yeah, they're the heating valve, the VT heating. That's not an issue. Gas-fired and boilers enabled, but it shouldn't be running, which it isn't. So it's not running there, it's disabled. Pumps are running, but that's only just to clear. Yeah, it's off. There's 10-minute delay on the pumps. So they will run for 10 minutes. But if there was a fire, we're not bothered about water pumps running. We're bothered about ventilation more than anything else. And of course, gas. That's it. Oh, season control. Never showed you that one. Not that we're using it, I don't think, in this logic as such, but I might have shown you on other jobs. Winter, summer mode set point, so anything 14 degrees or below is winter. And all this logic does is basically give me the seasons, winter, spring or summer, which goes into the optimizer. Optimizer, 0 is heating, 1 is cooling. We don't have any cooling here, so it's really not required because we don't have any cooling. So we're not bothered about cooling in summertime because we don't have anything to cool. That's it. Thank you.